time response of control system. This is the topic which we are going to learn today. Okay, so what is time response? What is the time response? It is the response of a control system, response of a control system as a function of time t. So it is represented as C of t. Usually, the response of the control system consists of two components. Okay, it is a combination of two components. What are those? One is the transient response. Okay, the other one is the steady state response. So, response of a system as a function of time t is called the time response of a system, and it is indicated as C of t. And this C of t consists of two components basically. One is the transient response, other one is steady state response. So we say that CT, the response time of a system, is combination of transient response and steady state response. So what is transient response? Let us see. Okay. So transient response CTT is the response which becomes zero as limit tending to infinity. For example, if I apply some input r of t, then the response of the system could be something like this. Okay, so this is having two components. One is the transient response, and the other one is steady state response. So transient response is indicated as defined as limit of t tending to infinity, Ct of t will become zero. That means transient response will become zero after a longer time. After as t tends to infinite, the transient response becomes zero. But even the transient response dies, the steady state response still exists. Okay, it exists to reach the final value. So you can see that even the transients are died off, the steady state remains to be present there. So this is the time response of a system. Generally, all the practical control systems, okay, all the practical control systems will exhibit the transient, exhibit the transient response. Okay, it will be there, and after some time it will die, and after that we'll be having the steady state response. Okay, now for example, if I say there is a response of a system, time response of a system C of t given as 10 plus 5 e to the power of minus t. Let us assume that. In that case, as limit t tending to infinity, 5 e to the power of minus t will be having 5 e to the power of minus infinity. As e to the power of minus infinity is 0, this becomes 0. That means to say that when I take a system whose transfer function is given as 10 plus 5 e to the power of minus t, then I say that here as time t tending to infinity, this term is becoming 0. then C of t will be remaining as 10. That means to say that if I look at this equation given to me, I say my time response E of t is having Css of t, which is 10, plus Ct of t, which is 5 e to the power of minus t, as limit t tending to infinity, Ct of t is 0. That means to say, as limit t tending to infinity, 5 e to the power of minus t is 5 e to the power of minus infinity is becoming 0. So this is one way in which mathematically we can see that if Ct is given, it is having both transient and steady state response. Then we have something called standard test signals. Okay, if at all we want to create disturbances which are similar to that of the physical disturbances, okay, with which we have to simulate the system and check how the system is working. For that, we have some standard test signals, namely step function. This is one test signal, and we have ramp function. We also have parabolic function. Depending upon the type of signal we want, we can take any one of them in order to test the system. Now, coming to the step function, okay, how do we define it? R of t is k for t greater than or equal to 0 and is equal to 0. This is for the units for the step function. So what we would like to say that how this step function is represented. Okay, so this is for t less than 0. I say that this is t and this is r of t. So r of t will be having a value of k for t greater than or equal to 0 and it is equal to 0 for t less than 0. This is the step C. Then if say k is equal to 1, we say r of t is equal to 1 for t greater than or equal to 0 and is equal to 0 for t less than 0, which is called unit step. Okay, if the magnitude is 1, we say it is unit step. Otherwise, it is unit. If it is not unit step, it can be value having k. K can be anything. Okay. Now coming to the other input, which is the ramp function. If you look at the ramp function again, r of t is given as kt for t greater than 0, which is equal to 0 for t less than 0. Okay. So how do we say it? You have r of t and you have t, which is having a linear slope. So which is rt is equal to kt for t greater than 0. If k is equal to 1, then r of t is equal to t for t greater than 0 is equal to 0 for t less than 0. Okay. So if we can say for r of t is equal to 1, you will be having same slope but unit slope. So the next one is about the parabolic signal, right? So for the parabolic function, the third standard set signal is parabolic function. So how is it defined? R of t is equal to kt square by 2 for t greater than 0 is equal to 0 for t less than 0. So we can have t r of t as a parabolic signal. If k is equal to 1, then r of t is equal to t square by 2 for t greater than 0 and is equal to 0 for t less than 0. So these are the standard test signals. Okay. Now what we can do is that if R of t is equal to k for t greater than or equal to 0 and 0 for t less than 0, if I take the time function as a step input, okay, let me find out Laplace transform of it, of R of t, which is equal to R of s. So Laplace transform of k, which is Laplace transform of 1, let us say, is k by s. You know Laplace transform of 1 is 1 by s. Laplace transform of k is k by s. Right? Similarly, for the ramp input, R of t is kt for t greater than 0 is equal to 0 for t less than 0. For this, the Laplace transform R of s would be Laplace transform of kt, which is equal to k by s square. Lastly, for a parabolic function, R of t is kt square by 2 for t greater than 0 is equal to 0 for t less than 0. In that case, the Laplace transform of it would be Laplace transform of kt square by 2, which is equal to k by s cube. So we have seen time response, definition of it. We have seen what are those steady state error and tangent error. And then we say that time response is a combination of steady state and a transient response, and there will be standard test signals, okay, like step, ramp, and parabolic. So to summarize, we have talked about different signals and their function, R of t, how do you express, and their Laplace transform. So if it is a step input, function R of t is equal to k, R of t is equal to 0. Laplace transform of it is k by s. For the ramp, R of t is kt for t greater than 0, 0 for t less than 0. The Laplace transform is k by s square. And for parabolic, R of t is kt square by 2 for t greater than or equal to 0 is equal to 0 for t less than 0. So it is greater than 0 and equal to 0 for t less than 0, the Laplace transform would be k by s cube. If it is unit step, then the Laplace transform would be 1 by s. For a unit ramp, that is when k is equal to 1, the Laplace transform is 1 by s square. For unit parabola, parabolic function, R of s is 1 by s cube. So this is about the time response of a system, then different standard test signals and their Laplace transform. Also remember there is something called u of t, step input, which says that it is 1 for t greater than 0 and is equal to 0 for t less than 0. So that is it about it. And next we will learn about what is the first order system, what is the second order system, and what is the response, step response of the first order and second order systems.